Now is it recording? We are all on section 1.1, parent functions and transformations. There are four main parent functions, and yesterday in your exploration, you went through a handful of these. Okay, you actually went through more than what we will today. Okay, you just took a look at them. Okay, the first one that they talk about is your constant function. Okay, yesterday you found that the graph to a constant function looks like this, correct? Everybody agree with that? Okay. Is it still a form of a linear function? Yes, it is a line, right? Okay. The equation for the parent function, which is the parent function is just like the standard equation, like the most basic form, was y, actually they use f of x now, f of x equals 1. Okay, that is the parent function for your constant function family. Okay. Why is it constant?
It's constantly across the x.
What will never change on this? The y will go up and down as this changes. Think of a line in slope-intercept form. The slope will never change, right? A constant function is always going to be perfectly horizontal. Okay? It has a slope of 0 or has no slope. Okay? That's our constant functions. It doesn't matter if I changed this 1 to a 7, this would go up to 7. Okay? This graph is just going to move up and down on the y-axis, depending on what this number is. Okay? But what they call the parent function, or the most basic form of this function family, the constants, is f of x equals 1. Is f of x the same thing as y? Yes. Okay? It's just what they're using is they're saying the function on x. So they're telling us this is what's happening to x. Okay? And we'll get some more examples here in a minute. The next one we have is linear. Get that graph out of the way. Okay. The next one is linear. Okay. Our graph from that one for the parent function looked like this, bless you. Okay. That graph can change a lot as we change certain things on it. We can translate it left, right, up, down. We can reflect it so it goes this other way. We can change the slope so that tilt of it changes. Okay, there's lots of different things that we can do to this graph. Okay, but that's the parent function there. The equation for the parent function is f of x equals x. Your slope is 1, and your y-intercept is 0. It's still in slope-intercept form like you guys are used to. It's just y equals 1x plus 0. Okay, it's just the most basic form of that graph. Okay, and we know if we give it a y-intercept of something other than 0, that's going to move it up and down, right? Okay, because that will be your y-intercept. But we'll get to some more of that here in a little bit. The next one is your absolute value. The parent function for this family has a graph. What shape was the absolute value function graph from yesterday? It was V-shaped, yep. Okay, so it's going to look like that. Can somebody explain to me why that graph never goes below the y, or excuse me, below the x-axis? Why is the y's never negative, Peyton? Absolute value cannot be negative. Regardless of what I plug in, whether it's a negative x value or a positive x value, my answer will always be positive for y, correct? Okay. So there's our parent function. What is the equation for our parent? Absolute value of x, right? Yep. Just like that. And from there we can shift it and move it, and we can actually, so we can reflect it, we can take this graph and lay it more open or tighten it up. And there's, again, lots of different things we can do to that graph as well. And the last one is our quadratic. Which has a graph for a parent function that looks like that. And the equation for your parent function is f of x equals x squared. The most basic form of a quadratic function. Okay. So we all looked at those yesterday. I think most of us ended up by the end of the day yesterday on our explorations, we had those correct. Now the next thing they're going to talk about, and I don't believe you actually have any problems on it today because I split this lesson into 2 days, but is what's called the domain and range. Have you guys heard of those words before? Domain and range? Does anybody know what they mean? Everybody's heard of them. Good. Which one's which?
Domain is x.
Domain is x, range is y. Okay? So the next thing we're going to do is we are going to distinguish what is the domain and range for each of these functions. Okay? So for this one, domain, which means, or what we're asking ourselves is, what can the x values be?
All real numbers.
All real numbers. There's no limitations. Notice this graph goes all the way left and all the way right. That's all my negatives, all my positives, and 0, right? Okay, so for this function, my constant is all real numbers. Okay. But does my y go all the way up and all the way down on that specific graph? No. So my range cannot be all real numbers. What can my y's equal in this scenario? One number. In this case, in this parent function, it would just be 1. Y equals 1. Okay? If this happened to be f of x equals 7, which would not be a parent function, but it would be shifted up 7, your range would just be that y equals 7. Okay? It's constant. This is a constant function because the range is always just one number. Okay? That line is never changing for your y value. No matter what you plug in for x, you're always going to get the same answer for y. Okay? Moving on to linear. Are my x's restricted here? Does the graph go all the way left and right? It does. So is there any restrictions for x again? No. So we're all real numbers here again. Okay. Are there any restrictions for my y's? When I plug in my x, is there anything I never could get? No. So we're all real numbers again. Okay. Absolute value. Is there any restrictions on my domain? No, I can plug whatever I want into an absolute value problem, can't I? Okay, so we're all real numbers. What about the range? Okay, could it equal 0? Yes, so not just greater than 0, but greater than or equal to 0. So y is greater than or equal to 0, because there is the only thing you can't get out of an absolute value function is a negative answer, right? Now, this one's tricky because if it's not the parent function, sometimes you can get a negative. Okay? If my graph was shifted down here, would my range change? Yeah, it would. It'd be greater than or equal to whatever this number is right here. Okay, so just be aware of that. Just because it's absolute value in the absolute value family does not mean it can't be negative. Okay, and I think we do an example here. Oh, it doesn't go negative, so I'll just show you one. For example, this. F of x equals the absolute value of x minus 3. That can be negative because if I plug 1 in, or even if I plug negative 1 in, this is positive 1, minus 3 is negative 2. So it's still an absolute in the absolute value family, but then minus 3 is on the outside, therefore making our answer actually be negative. So in this case, it'd be y is greater than or equal to negative 3, because this graph would be shifted down to negative 3. Okay, so just be aware of that. Just because it's in the absolute value family does not mean the answer cannot be negative. And our quadratic, is there any restrictions on my domain? What about my range? Same thing, right? Y is greater than or equal to 0. Same thing with the absolute value. That could change, right? Okay, another thing I didn't mention on absolute value is it possible I do a reflection and my parabola goes this way? In which case it would be y is less than or equal to, right? So be careful with that. That is a possibility. Okay. Real quick, taking a look at example 1. It says identify the function family to which f belongs. Lainey, what family does that graph belong to in example 1? The absolute value family. Good. Okay. Next thing they want us to do is compare the graph to the graph of its parent function. Okay. So where is this graph from the parent function, Brody? It's up, right? So it's shifted up 1. Okay? And that's very easy to see. What in the equation, based on the fact that you know what the parent function looks like, and you can see this equation, what number do you suppose shifted that graph up 1 in the equation? The plus 1 did. Okay, so what I want you to do is take that paper I gave you, flip over to where I showed you polynomial transformations. Now shifting up, is that a vertical or a horizontal translation? Vertical. Notice on the vertical translation, I have f of x plus k, which means I'm taking the whole function and adding some number, right? Whatever that k is how far up or down you move. Okay, no matter what, whether we're talking absolute value, quadratic, linear, constant, we'll get to cubics, it doesn't matter. If I put plus 7 on the right side, on the far right, we're going up 7. Okay, it's kind of like with a linear, your y-intercept, right? Okay. So, also, that graph, and that it's a little harder to see, and we'll work more with this later, it's actually tightened up a little bit too. Well, if the 1 moved it up, the only other thing that could have done that was the 2. Okay, so we'll talk about that. The 2 is actually going to tighten that graph up a little bit. Okay, so going on, we're on page 5 now. Transformations. We talked about transformations quite a bit last year in geometry. There was 3 main ones that we did. What were they? Reflection, translation, rotation. Those are the 3 main ones. Okay? We're not going to do the rotation stuff right now. We're basically just working with reflections and translations. Okay? But all that stuff was kind of preparing us for it. So, first one we're going to do is a translation, which is just doing what to something? Move, like shifting it, right? Shifting it left, right, up, or down. Okay, so that's what we're working with first. We'll look at example 2. I'm actually going to do the extra one in the textbook because it's actually a little bit harder. Okay, so the one that I have is g of x equals the absolute value of x plus 1. Okay, so that's the function I have. And the directions say to graph this function and its parent function and then describe the transformation. Okay. Well, to graph something, it's probably been a while since you guys have graphed anything on a coordinate plane, because we didn't exactly do a lot of that in geometry. We're just going to make an XY chart. Now, I know some of these are going to be pretty easy, okay, but some of the more difficult ones, you're going to want to just chart this out. I would suggest starting with -2, -1, 0, 1, and 2. Okay, just typically the easiest 5 numbers to plug in. So when I plug in -2, I get -2 plus 1, which is -1, so the answer is +1. When I plug in -1, I get 0. When I plug in 0, I get 1. When I plug in 1, I get 2. When I plug in 2, I get 3. So I have -2, 1, -1, 0, 0, 1, 1, 2, and 2, 3. Okay, so it's pretty clear to me that's going to be an absolute value function for a couple reasons. First of all, the graph, but also because it's got the absolute value signs, right? Okay, so I'm just going to add that extra point. If you needed to plug in -2, or excuse me, -3, you would have got 2, right? Yeah. Okay, so I have this graph now. So there's my function, g of x equals absolute value of x plus 1. They also want me to graph the parent function. Well, I know that that's the absolute value parent function, so I know it's 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. Okay, so now I have my new function in red, my parent function in blue. They want me to describe the translation. So what happened from the blue parent function to get to the red? I went 1 unit to the left. Everybody agree with that? Bless you. Okay. This is where things tend to get a little confusing. So pull out your sheet again. We know that was horizontal, right? So I went to the left. So I'm looking at the very top row. I have there f of x minus h. So notice I didn't... Well, first of all, let's talk about it like this. See on the far right column where I have inputs and outputs? What are inputs and outputs back when, like, first grade when you did the input-output machine? Inputs go in and outputs come out. So inputs are your, which would be what values? X or Y? X is because I'm plugging in X. Outputs would be what it kicks out as a Y, right? Okay. So if it says inputs, that means I am only doing something or changing something to just the X value. Okay. If it says outputs, it means I'm changing everything. Okay, I'm changing the entire function. So we'll do some examples here in a second where hopefully that clears up. But notice horizontal translation is for the inputs only, so I'm only changing X. Okay? But this says +1, but we went left. Look at that sheet I gave you and explain that to me. How did that say +1, but I went left 1? So what I actually have there is f of x minus h, right? And that's actually an absolute value. So I actually have x minus h, right? So if h was -1, which would tell me I went left 1, when I plugged that in, I actually ended up with x +1, right? Which is what my function was. Okay, so that's tricky. That tricks a lot of people because we see plus, we want to think to the right. Okay, but if you're doing it to only the x, that's always a minus sign right here. So it's always going to be opposite. Okay, so just be careful with that. Hopefully by the time we do a bunch of practice problems, you have that mastered. Okay. The last example I want to do for today, and then you'll work on half your homework. We'll finish the lesson tomorrow. Maybe if this works right. There we go. I have the function k of x equals -x. They want me to graph this and its parent function and then describe the transformation. Okay. This one should probably be pretty easy to graph. You might not even need to make a chart for this one. Okay, I want to make sure I do these in the same colors. Red first. Okay, -2. I'm going to plug -2 in and get +2. So -2, +2. -1, +1. 0, 0. 1, -1. 2, -2. Okay, so I went ahead, I plugged in 5 points. I ended up getting a line. What's the parent function to this graph? F of x equals x. It's in what family? Linear. Good. Okay, so there's my parent graph. The question is, describe the transformation. Is it just a translation? Yeah, it's not a translation at all, right? It's a reflection. Okay. Now the question is, did I reflect in the x or the y? Either, right? You said both, but I know what you mean. Either. I could have taken this point and moved it here, or I could have taken it and moved it up here. I'd have got the same graph, right? Okay. So take a look back at your sheet. Okay. A reflection in the x-axis would have changed would have changed the outputs, right? Which means I'd have changed everything that I had. which would have gave me that same graph. A reflection in the y-axis would have changed only the x value, right? Okay, and it's not going to matter which one of those you say in this case. Now, I want to show you an example real quick here of what happens if I want to do that to a more complex problem. For example, let's say I have y equals 3x minus 7. Okay. First, I want to reflect it in the y. Okay. If I reflect it in the y-axis, going back to our sheet, do I change the inputs or the outputs? The inputs, meaning just x, right? Okay, so if I were doing that, this is how I would write it. I'd do y equals 3 negative x, because notice they're on the left side, or in the middle column, excuse me, all we're doing is just putting a negative sign somewhere, right? So I put the negative with the x, and then I still have minus 7. So the only thing that I changed was what that x, instead of a positive x, it's now a negative x. Okay? That's going to reflect it in the y-axis. Now if I simplify this out, I get y equals, what would this give me? Negative 3x minus 7. So it changed this negative 3, or to a negative 3, but it didn't change my 7, right? Okay. If I were going to reflect in the x-axis, it says I have to change the outputs, which would be changing everything, right? So I know this equation's pretty simple, but sometimes they'll get more complex. I would write it like this. I would show myself I got to change all the signs. Okay? So then for my answer, I'd have negative 3x plus 7, right? Okay. So just be careful with that. Understand the difference between inputs and outputs and what you are changing. Okay, we don't actually see this chart that I gave you until, I don't even remember what chapter, it's way later, like maybe almost even second semester. Okay, but I decided to give it to you right away because I think if you just go off of this chart from the beginning, I think you will understand it better than we did last year because they didn't give us this chart until later. Okay, any questions on that? Okay, you should, for tomorrow, you should be able to get all the way through problem number 18. Okay, you should be able to do 1 through 18 now. And that assignment is online.